So, this is probably Monday of next week for you. Yep, Monday of this week. And you had homework on 3-4, which, by the way, I had that labeled wrong last time. It's section 4, not section 3, but you had the handout. So you had to do this either in class or you did it for homework. And I'm gonna go over 2 problems before I do section 3-4, day 2, okay? So you did day 1 without me on Friday, and you had some homework, all right? So I'm gonna go over just a couple that I'm predicting you may have had a little trouble on. Did you know how to graph the equations in 4, 5, and 6? So in number 5, they gave you this equation, right? And we said that in a direct variation equation, this is the constant of variation, but it's also the slope. And we know that these direct variations always pass through the origin. So to graph this, I would start at the origin, and I know that I have a slope of -3/4. Now if the slope is -3/4, we have a choice. We can either put that negative on top, or we could put it on the bottom. Alright, so let's try both ways of doing that and see that we get the same answer, okay? So if we had a slope of -3/4, we would go down 3 and right 4, right? Its rise is -3, its run is +4. And if we put that negative on the bottom, can you see Mojo in this picture?
He's just peeking his head in
Okay.
the frame right now. He's
And my
peeking.
dog wants to be in it again. Alright,
Oh,
sorry.
okay.
Wants to get the eraser on the table. Moji, Moji, no, Moji, no.
It's like closer to where he made it.
Okay, alright, I'm
Wait a
back.
second, wait a second.
Alright.
Before, we'll just edit this part out.
Why don't we,
What do you want?
Love
me to do?
you.
What do you want me to do with it?
put it right there. Okay. Love you, buddies. Love you, fuzzy buddies. Okay. Alright, so, as I was saying,
No, okay.
we are graphing this equation, and so we know this is a slope. And the -3/4 can be thought of as a -3 over +4 or +3 over -4. And if we graph it as a -3 over +4, down 3 over 4. But if we graph it as a +3 over -4, we would go up 3 and left 4. Right, so notice that regardless of how we do it, we're gonna get the same line, okay? Just don't put the negative on both, because if you do, what do we have? Positive. Alright, so we're gonna put it on one or the other, okay? Alright, so as you're checking your answers on this, remember I do wanna see some work. Obviously on number 5 you can't show work, but on 7, 8, 9, 10, 11 you, and 12 you should have work there, okay? Let me do one more of those from the homework. Okay, so, for the majority of the homework problems, you had to do 2 things. You had to write a direct variation equation that relates x and y, and then you had to solve. So, they're all kind of the same. Probably one is not any harder than the other in this particular handout. They're all integers, so I'll just pick one of them. So one on the back side, maybe with negatives in it, maybe number 10. Okay. So just to review this, if you're given, right, I'm given if y equals -9, when n equals n, when x equals 3, and I want to find y when x equals -5. Okay, so two things we need to do. We need to find the equation. So we start out with y equals kx. And then we plug in what we know, right? So we know y is -9 and x is +3. When you divide both sides by 3, +3, you get an answer of -3. And you don't want to just circle that and be done with it. What you want to do is you want to make sure you write the equation. So the equation is y equals -3x. And this is the direct variation
He won't be stopped, he needs attention.
equation. You can't have this eraser, buddy, I need it. Once you have the equation, you can then plug in x or y to find the other variable, right? So they wanted us to find the equation, and then they want us to use the equation. So the equation is y equals -3x. They want to know y when x is -5. So we just plug in the -5 and simplify. So -3 times -5 is +15. Okay. All right. So that's it for going over the homework. All right, what we need to do is we need to talk about applications. So, word problems with direct variation. You might have a little bit of deja vu when we're doing these, because these are going to seem an awful lot like the proportion word problems that we did, and you were all very good at those, so. But I gotta just explain kind of what the expectation is in this section. Can you make sure that everything's in the picture?
Yeah, everything's
It
in
is?
frame.
Okay.
Everything's in frame.
Alright, so this is 3 for day 2. So you have this notes handout. Okay, so direct variation problems. If you think about the distance formula that we just used, right? The distance formula is a direct variation equation. In the formula, the distance d varies directly as the time. Okay, so this is very similar to y equals kx. So here we say y varies directly as x, but with distance equals rate times time, we say the distance varies directly with the time. So that means that at a constant rate, the distance we travel is directly related to how much time we're traveling. Okay, wait, we're doing time travel? What are we, going back to the future?
What are you doing?
I'm being my goofy self like I normally am in class. That's what the crowd expects, Owen, okay?
Okay.
Gotta crack them up along the way here, right?
Mhm.
Alright, so, in this particular problem, we know a family drove their car 225 miles in 5 hours. Okay. So, if that's true, right, just like the y equals kx problems, we can create an equation based on this information, okay? So 225 miles is the distance, 5 hours is the time. So we can write an equation. We can say, right, if we know distance equals rate times time, we can say that 225 equals the rate times 5. And then we can solve for the rate. So we get the rate is equal to, I think it's 45. Yes, it is. Okay. So just like finding k, we found the constant of variation, we can write the equation. Right? So the equation that they're giving us, or that we found, is d equals 45t. So we can create a graph from that by using the same theory that we just did in that homework problem. We only really need quadrant 1 here, okay? And so if the time is 1, then the distance is 45. So if we can scale it differently here. Okay, it looks like a slope of 1, but that's because you have to look at the axis, right? They went by 90s on the sheet, okay? So, once you have the equation, just like the previous problems, you can use the equation to then find out other information, right? So it says, estimate how many hours it would take the family to drive 360 miles. Well, now that we have this equation, right, if we want to figure that out, we can just say, right, if we know that D equals 360, we're looking for T. Okay? Can this be seen?
Okay.
Okay.
Two,
Right.
two frames.
So what we do is we take what we know, right? We already found this equation, and we substitute in the value of D. So we have 360 equals 45 times T. And we know how to solve that equation. Dividing both sides by 45 gives us a time of 8 hours. Okay. Now, just think back to when we did proportional reasoning and proportion word problems. We didn't really go through the process of finding the rate. We used proportions to solve by setting up our ratios in an organized way. So I know this is not on the handout, but just bear with me for a second here. All right, think about how you would have done that back in chapter 2. Okay. It says a family drove a car 225 miles in 5 hours. And then the ultimate question in part C was estimate how many hours it would take the family to drive 360 miles. Right? So back in chapter 2, we used our proportional reasoning. Right? We set it up in a very organized way. We didn't know what this was. We can call it X, not question mark. And we can say, well, if we have miles over hours, then that should equal miles over hours. So if we go 225 miles in 5 hours, right? If we're staying at the same speed, how many miles, 360 miles in X hours. And so we could solve our problem like this. Right? How would we solve it? You're right, cross multiply. Cross multiply. So you have 225x equals 360 times 5. Right, and in the end you'd get the same answer. You'd get x equals 8, okay, which is really the time. Now, I'm talking about this right now because I want you to know that you can still solve those problems like this. Okay, this method is great to estimate the unknown, but that's not going to give me a direct variation equation. So if they ask you for the direct variation equation, you have to go through that process of finding the equation. You can't just go to the final answer, okay? Because we're going to use these equations for other things. All right? Okay, let's take a look at retail question number 1, and then I'll have you do number 2. Okay, so exercise number 1, retail. It says the total cost C of bulk jelly beans is $4.49 times the number of pounds P. and that is equal to our total cost. Right? So that is, right, the cost C is 449 times the number of pounds. So this, once again, just like D equals RT, looks like Y equals KX, right? Similar scenario. So this price per pound is the constant of variation. Just like the rate, how fast the car was going, was the constant of variation. Once we have our equation, we can make a graph, and when we graph it on the grid, right? So once again, this is the slope, remember, but it's kind of hard to graph that as a decimal. What they did was they went up by 450 because that was awful close to 449, right? So they have 0, 0, because again, all of these direct variations pass through the origin. And we want to get just a couple more points. So we could say, we could make a little chart, right? Or we could do the slope, right? Here, obviously, plug in 1, you're going to pay 449. If you buy 2 pounds, 2 times 449 would be, let's see, 450 would be $9. So that's going to be 2 cents shy, so $8.98. Right? So I'm just going to estimate, it's almost up there, right? And almost to the $9. Okay? So we have our graph of how the cost is increasing based on the weight in pounds. Okay. And once again, the slope is the constant of variation. And now they want us to figure out, find the cost of 3/4 of a pound. So this was part A, this is part B, and part C. Find the cost of 3/4 of a pound of jelly beans. So we need to figure out which variable that is, right? 3/4 of a pound, that's the variable P for pounds. So the cost is equal to 449 times 3/4, which we could write as a fraction or a decimal. And so when we substitute that value in, what do we get? I don't know, pick up your calculator, you tell me. Now, this is what my calculator tells me, 3.3675. But if we're talking about money, how many decimal places do we look at? Right? We've got the nearest penny, but to the right of that is a 7, so that's going to round the 6 up to a 7. So $3.37 would be the correct answer. Remember, when we're talking about money, we're rounding to the nearest hundredth. Okay, folks, I'd like you to now try on your note sheet the problem on the back side. It's about chemistry, Charles's law. All right, do that now. Put me on pause.